So in this video we'll be going over half-life reactions and their formulas for each reaction order. So as you can see, I have made a table for the three formulas that you have to memorize for this video. So the first one is order 0, 1 and 2, and these are the corresponding formulas. And you might ask, what is a half-life mean? So it is basically the amount of time for the reaction to use half of the reactant in the chemical reaction. So now let's look at some examples and will be more clear. So in this question, it is a first order reaction which has a half-life of 63.4 minutes at this temperature. Temperature does not matter. And then it's asking you to calculate the rate constant for the reaction. So now let's get the formula for first order. So first order is ln2 over k. K is the rate constant, and we have the half-life, which is, I'm gonna write as t, which is gonna be 63.4. So now let's plug in the values. So it's gonna be 63.4 is equal to ln2 over k, and now you can do shift solve on your calculator and find the exact value of k here, and it is 0.0 Okay, so this is the final answer, and we're going to leave it in 3 significant figures since the question has 3 significant figures. Let's move on to the next question. So in this question, it is a second order process, so you always have to check which order it is first, and it has given you the rate constant, which is equal to 5.13 times 10 to the power of negative 4 at some temperature, and now it's asking you to calculate the half-life with the initial concentration of AB is equal to 0.23. So now let's write the formula first. So this is the formula for second order. Now if we plug in the values, we will get that T is equal to 1 over the rate constant as given in the question here, and then the concentration, which is 0.23, and now if we just solve this, we'll get T is equal to 8,475. So now let's move on to the second question, which is B, and here it says that the same reaction has a half-life of 45 minutes when carried out at this temperature, doesn't matter, with the initial concentration of 0.23, and now this is asking the rate constant for this specific temperature. So we have to use the same formula but with different numbers, and we need to calculate the rate constant here. So as you can see, T, which is 45, is equal to 1 over K, which we need to find, times 0.23, which is the concentration. And now if we do shift solve on our calculator and find the value for K, K is going to be 0.0966. Let's move on to the next question then. So in this question, it is again a first order reaction, and they have given you the rate constant, which is gonna be 3.62 times 10 to the power of negative 4, and the unit here is in seconds inverse, and then they ask you to calculate the half-life in minutes. So this is one important thing that you have to see in the exam. So let's start by writing the formula again. So the formula is ln2 over k, and if you have k in the units of seconds, it will give you the answer of t, which is the half-life time in seconds. So now let's just do that for now. So it's going to be ln2 over 3.62 times 10 to the power of negative 4, and this gives you the answer of 19414. Let's keep 877 to be exact, and this is in seconds now. So now the answer is asking you to calculate it in minutes. So a simple step you have to just do is divide this answer, 1914777 divided by 60. That's it. So now this will give you the answer in minutes now, which is going to be 31.9 minutes. So that's all for this video. If you have any questions, you can ask in the comment section and I'll be happy to respond, and I'll see you guys in the next video then. Bye.